Okay, guys, your second video for this week. We're going to take a look at volume. That's kind of the last thing we left off with before spring break. And so hopefully I made this smart or the dry erase board. Hopefully you think it's really cool. Then the accent wall, that's my wife's idea. She did a great job putting that together. So give you a little bit more tour of my home later on. But let's get down to the mathematics right now. We have example one, and we're going to take a look at y is equal to 1/2 x squared, and x is equal to 3. Okay, and we're going to revolve that around the x-axis. Okay, and so if we can consider that x is equal to 3, that's a vertical line. Okay, then x squared, we're not really concerned about this part of it, but we are concerned about this part. 1/2 x squared, it's going to look something like that. What we're going to do is we're going to take this region and we're going to spin it around. So if I were to draw a rectangle in place there, see that little rectangle, if I were to spin that around, notice what I get. I get this kind of a shape. Call it a disc. And the way that we find the volume of a disc is, we have a radius there. We take, boy, that's reflecting right on there, isn't it? We'll try that. So light or no light, hard to tell sometimes. Have some light fading in from back over here. We're just having supper, but we'll try like this. Sorry about that. So we've got r. So the area is going to be pi r squared. And in order to find the volume, we multiply by the width. Now here, the width is a horizontal width. Horizontal width. So we call that dx. So dx. Well, how do we find the radius? Well, in this case, the radius happens to be the function. If you look, what determines the height? The height, y equals 1/2 x squared. That is, in fact, your radius. So the volume of one of these discs is going to be pi times 1/2 x squared, because that's your radius, dx. Now, we don't want just one of those. We want an infinite number, so we slap on an integral. And you look at our original area here. We're going from 0 to whatever this x value is. It's determined for us that, in this case, the x value is 3. That works out quite nice. We go from 0 to 3. And now that we have the integral set up, the rest is quite easy. Pi times integral. I'm going to square that. I get x to the 4th over 4 dx from 0 to 2. The antiderivative of x to the 4th over 4 is going to be x to the 5th over 20. Or multiply that by pi. We're going to evaluate that at 2 and at 0. We plug in 2. 2 to the 5th is 32. So 32 pi over 20. 32 and 20 are both divisible by 4. So if you divide those by 4, we get 8 pi over 5. That's going to be the volume of that solid revolved around the x-axis. Okay, so see it nicely laid out there. Yeah, nice problem. Works out pretty well. I'm not going to try to get to really complicated ones for you guys. We're going to try to keep them fairly basic. Some of you guys, when you take Calculus 2, you'll actually review this content again. Some colleges, this is Calculus 2 content. Other colleges, this is still kind of Calculus 1 stuff. Really depends on where you go. Everybody breaks it up a little bit differently. But let's look at our second example. Example number 2. And what we're going to consider in this situation is y equals 1/2 x and y equals 3. The area bounded between those around the y-axis. And so this looks very similar to the last problem. Instead of a 1/2 x squared, I just have 1/2 x. Instead of x equals 3, I have y equals 3. But there is, quite a change that's going on here. And so let's see if we can pick up what that is. It starts as you look at the actual area that you're working with. 1/2 x is a line with a slope of 1/2. So it looks something like that. And then y equals 3, 1, 2, 3. Looks like that. So you kind of see this region right here that we're working with. But instead of revolving around the x-axis, we're revolving around the y-axis. And so if you revolve around the y-axis, it's a horizontal revolution. Instead of drawing a vertical rectangle, we're drawing a horizontal rectangle. And again, as you do revolve that around, you can see this nice disc shape that you're getting. I would encourage you guys in your work, you're using that equation editor to kind of submit your answers. But I encourage you to draw this out and work them out on a sheet of paper. I haven't given you that many problems, so it really shouldn't take you that much more time. But you can see we have this type of disc going on here. Okay? So that's good. We find a volume of a disc. We have pi r squared. In this case, we have vertical thickness, so dy, and our radius. If you look at the function that determines our radius, it's that guy there. So pi times 1/2 x squared dy. You notice the problem? Hopefully you can recognize by looking at this that these variables don't match. They have to match. If you're integrating with respect to dy, then you must make sure that this variable has a y in it. So we're going to look back at this guy. We simply multiply both sides by 2. We get 2y is equal to x. So therefore, that's my substitution there. So I have pi times 2y quantity squared dy. That would be the volume of one disk. You want an infinite number, slap on that integral. We're integrating now top to bottom, okay? So instead of going side to side here, going like this. So what is this spot right here? That's 3. And then the bottom is 0 in this case. So I have pi times integral 0 to 3 of 4y squared dy. Antiderivative of 4y squared is going to be 4y cubed over 3. We're going to multiply that pi, and we're going to determine or evaluate that at 3 and it's 0. Do some tricky math here. We've got, we're plugging 3 to the third is 27, divided by 3 is 9. 9 times 4 is 36, so 36 pi. Really nice number there, but that's what we get. So yeah, it works out pretty well. So there's a review for you, dx, dy for area as well as for volume. Should be able to handle the first week's work. I'm just making sure that this all works before I publish any other kind of videos, but I promise we'll get to some birthdays, office references, and things like that as the weeks kind of go along. So miss you guys. Stay safe, stay healthy. Let me know if you got any questions. I'd love to sit down and do some math with you via online.